So we are ready to start for the next talk. We have Oliver with a talk on air quality and pollution and how to be a good citizen with your data science project. Yep. Please welcome Oliver.
Hi everyone, I'm Oliver Crask and I'm currently a student at the University of Leicester. I'm studying physics and today I'm going to be talking about my project on personalised air quality monitoring. So I'll start by talking about a bit about air pollution and why it's important to monitor it, and then a bit about my project and how it works, and lastly some of the analytics I've produced so far. So we'll go straight into it. Air pollution. So air pollution is a big problem and it's increasing all the time, both in the UK and around the world. Causes a lot of deaths, unfortunately, and it's getting worse. You might be familiar with images like this of smog, but really pollution levels can be high and you can't see them. So so smog's caused by particulates, but the gaseous pollutants you can't see in the air, so they're definitely a concern as well. Now, I'm sure many of you are familiar with the concerns of outdoor air pollution, so air pollution caused by vehicles, etc. How many of you have tried to reduce your pollution exposure, for instance? Yeah, a few of you. But how many of you have thought about indoor air pollution and its concerns? Oh, a few as well. All right. So as it says there, indoor air pollution could be 2 to 5 times worse, which I found quite surprising, really. So I started looking into that a bit, and I'll show you some data for that later. And yeah, the major pollutants are particulates, and then 3 gases: nitrogen dioxide, ozone, and sulfur dioxide. So they're the main ones you should be concerned about, really. So for my project, I chose to focus on particulates. Both because they are very harmful and they're the easiest to measure because they're not a gas. Particulates are pretty much any matter that's suspended in the air, so that covers pollen and mold and smoke and dust and anything like that, really. It's kind of like a catch-all term. And the size of the particles and the toxicity determine how dangerous they are. So there's a diagram on the top left there. I don't know if you can see it very well. For particles that are smaller than 10 micrometers, you're looking at decreased lung function. Less than 2.5 can cause skin and eye diseases, less than 1 tumours, and less than 0.1 severe diseases like cardiovascular and heart problems. So yeah, pretty nasty stuff, really. Yeah, so that's why I chose to focus on them for my project. So what is it? I've made a device using a Raspberry Pi Zero and a couple of low-cost sensors and a USB cellular device, which is the hologram Nova. And the idea is that you carry this around with you and you'll be able to get personalised data on your exposure to pollutants. So whereas you might be able to get access to data for your city or your street, you don't really know what exactly you're breathing on a day-to-day basis. So that's where my project kind of tries to fill that gap. And the idea is you collect data of, for instance, your journey to work, and then you know which areas to avoid in the future and just improve your air and enable you to also encourage government to move towards cleaner air using that data. And it's just, at the moment I'm powering it with a USB power bank. And there's a write-up on Hackster.io at tinyurl.com/particulator if you want to make your own. It's quite simple to get started. I've written in detail all the code you need and how to connect the devices together. I'll put the link at the end of the presentation as well. So the sensors I'm using 2 different ones. I'm using the PM-S5003, which measures particulates, and it does it in 3 distinct categories: PM1, 2.5, and 10. These are the main bins, kind of, that is used typically for measuring particulates. So that's less than 1 micron, less than 2.5, and less than 10. And then I'm also using a BME 280, which is just to provide environmental variables, temperature, humidity, pressure. They're useful for calibration, but at the moment I'm just using them just to have more data because it's nice. So how does the device work? So it starts with the Raspberry Pi Zero. It frequently polls the data from the two sensors. That's then uploaded using the USB cellular device over 3G to something called the hologram cloud. And that's kind of like a cloud-based IoT device management service. If that makes sense. So you can connect as many devices as you want to that, and then pass that data on to an endpoint, in this case a REST API query. And that goes to something called a Home Assistant, which I'm running on a Raspberry Pi in my house. So I can carry the device anywhere, and the data will end up on a SQLite database on my Raspberry Pi in my house. So a bit about what Home Assistant is. It's an open source smart home platform, and what that means is you can connect a whole array of devices to it. If you have any smart home devices like lights or door or window sensors, that kind of stuff, you can connect that into there. Connect with Alexa and what's it called, Chromecast, an array of different devices really, and you can produce these dashboards where you can interface with those. For instance, in this demo, there's somebody's attached their bonsai onto there, so they can see the humidity and temperature and light intensity that it's exposed to, and then you can use these values to kind of like automate your home. So for instance, if it's raining outside, you can turn your lights blue so you know you need to take an umbrella, and that kind of stuff really. All data is stored locally, so you don't have to worry about privacy issues, etc. And if you want to get started, just go to homeassistant.io and you can learn more about that tool. So how did I integrate my project with Home Assistant? Well, you can create something called a custom component, and what that does is it's basically a small bit of Python code that Home Assistant runs at an interval, and in this case pulls the data from Hologram Cloud and then passes it out into individual variables. So as you can see here, I've set up a card in Home Assistant, and that gives me PM1, 2.5, 10, temperature, humidity, pressure. So you can just visualize the data as they come through in real time. So I started looking at analytics. This is just some basic analytics I did when I just got started with it. So I looked at, for instance, when I was soldering, what effect that had on the air quality. As you can see, it produced a pretty big spike up to 100 micrograms per meter cubed, which is a concentration measurement. So that's quite a considerable level. I then looked at the effects of frying, and the last one I didn't plan for. So one of my housemates isn't the best at cooking, and they managed to completely burn some sausages that they left on and forgot about, and the house filled with smoke. And I could pick that up on my sensor off in my bedroom. So it was interesting to see that. And I also got a notification on my phone to warn me of high particulate levels. So yeah, it's interesting, the effect of ad hoc events and things like that. So next I started looking at something called Grafana, which is an open source tool you might be familiar with for making plots and gauges and just looking at data in more detail. It just reads off the SQLite database that Home Assistant uses, and it integrates directly via an add-on, which means that the data is immediately updated. I can't see it very well here. It's a bit of a shame. I'll just try and describe it a bit. Okay, this is a dashboard I made. You just drag and drop the, it's like drag and drop tiles, kind of. So the one on the top left is a plot of particulate concentration. And I've got PM1, 2.5 and 10 on the same plot there. You can see they kind of follow the same trend. I've got temperature, humidity up on the right, which you can barely see. And then I've got pressure below that and some live gauges, which just update in real time to show you the particulate levels, and you can color code those so you get like a visual idea of whether the pollutant levels are high or not. And that's at grafana.com if you're interested. So next I started looking at what would the effect be of some of the day-to-day activities you might go through. So I record the effects of using a spray deodorant and hairspray. Don't use hairspray myself, but a lot of people do, I suppose. So as you can see, it produced a big spike. It started around 4 or 5 micrograms and then up to 65, 70. And I've included a scale on the bottom right there, and that's the UK index for air quality, so you kind of get an idea of what those values mean. So a value of 65 is considered high and heading towards the very high end of the spectrum there. So that was interesting. And you can see that PM10 is a lot higher than PM2.5 and 1 on there. So next I looked at the effect of using cleaning products. So I think most people will be aware that cleaning products aren't the best for your indoor air quality. So I looked at the effects of using air freshener, wood polish and carpet cleaner. And you can see a couple of noticeable spikes on there. Just for reference, when there's just in a static room, you'll get a pretty constant level. So these spikes are definitely caused by using those products. And you can see they go up to about, what was that, 30 and 50 at one point. So that's fairly significant. And at the same time, they also produce volatile organic compounds, which you don't really want to be breathing in. Yeah, so that was interesting. And then I also looked at the effects of cooking. Now this one surprised me quite a bit. I assumed there would be some, but I didn't really realise the extent. So I was grilling some cheese on toast for 20 minutes, and that produced concentrations over 200 for PM2.5, which is definitely really high. Way off the scale even. It's given by the UK government there. And those values sustained for several hours, so it does really identify the issues with indoor air pollution and how important adequate ventilation is really in a home. So you should really use extraction fans whenever you can, or open windows, etc. Yeah, and as you can see, it kind of tails off to about 100, but that's still a lot more than you should be exposed to. So I found that pretty interesting. So what do I hope to do with this next? Well, I hope to incorporate GPS data, so that the idea would be you can carry it around and then produce a map from that data and see which areas are kind of like pollution hotspots in your area. So I've started working on one. This is just with dummy data at the moment, but it's all in place to like receive the data from the database. So as you can see, there's a color scale on there, and that just represents different pollutant levels for particulates. I've got one of these plots for each PM1, PM2.5 and PM10, and yeah, it's coming along, so that's going to be coming soon, and that's using bokeh. I'd also like to develop a predictive model, so the idea would be you could see the pollution levels that are coming up in the next day or tomorrow, and then that would be really beneficial to people that suffer from COPD or asthma, and help them to reduce their exposure further to these pollutants. And lastly, I hope to develop a low power solution. So at the moment, Raspberry Pis and USB stereo devices, they're quite power hungry. So they're not ideal for this application, but they work as like a demonstrator. So I plan on working on something maybe with MicroPython. That would be interesting to get into. And maybe use a low power radio protocol like LoRa. Currently looking at different possibilities, but that should be interesting, so watch this space. That concludes my talk. So, yeah.
Okay, first and second there.
So when you showed that graph of the particulates when you were cooking, it's way above the recommended level, but is there are all particulates of a given size created equal? Like, as in, are they equally damaging just as a virtue of their size, or does it vary depending on what the actual particulate is?
It's a good question. I forgot to mention that. So particulate size is probably the main aspect of that. So the smaller particles are, the further they get into your bloodstream and around your body, so you don't really want that. But at the same time, the toxicity of the particle is also pretty important. So yes, there is some element of that. I'm not sure how you'd measure that, but yeah, it does play a part as well.
Was a question? Yeah.
Do you have any sense on how effective extractor fans are and windows at removing particulates from the air?
Living in a student house, unfortunately, we don't have an extraction fan. So I haven't been able to test that. However, windows are very effective. If you're in a static room, then the particulates stay constant for a long time, even if you have high levels. So yeah, windows make a big difference, really. I think that should be something people are more aware of, really.
You talked about VOCs. There's various sensors nowadays. You're going to expand the system to include that as well?
Yeah, so I hope to. I'm looking into VOCs, and then there are also some gas sensors, but they're also quite a lot more expensive. So I think I'll just probably focus on VOC and maybe ozone and look into those next. And yeah, it'd be good to get some more data from that as well.
Any more questions here at the front?
Yeah, so air quality is actually becoming more of a thing for companies to start thinking about. Have you thought about sort of putting this into offices and things?
So there are already quite a few solutions, say, to provide to councils so they can monitor air quality on streets and in their own buildings. So this was more a focus on the citizen side of things. However, it could easily be scaled up for that kind of application. So I'll quickly go back through. That's something I forgot to mention. You probably saw the picture of the pigeon. So this little guy. In London, there was a study where they released a whole flock of pigeons with little sensors on the back, and they flew around London, and you could tweet the pigeons, and then find out about, well, you kind of get the value of air quality from the pigeon that's nearest to you back as a tweet. So that was really cool. So yeah, a lot of companies are now getting more involved into this side of things. I think there's a lot of space for it to expand in the future.
Any other question? Yeah, at the back.
This slightly more traditional kind of question about air pollution, but I just wonder what your thoughts are on monitoring people's interaction with kind of the big kind of energy appliances that they use and which kind of associate with air pollution. So diesel cars, gas boilers, wood stoves, those kinds of appliances.
In what sense?
I guess the potential of your project draw attention to,
Okay. Yeah, I can see the relevance of that. It's not something I'm going to focus on at the moment, but I can definitely see the value of trying to show which kind of things people should avoid. So I started doing that by looking at the different indoor aspects, but then also looking at the effect of diesel cars versus electric, or just more outside side of things as well would also be pretty relevant, I think. Worth looking into.
Any last question? Let's thank Oliver one more time.